Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about reverberation and critical mass. I want you to start thinking in more treatment terms, especially churches and larger venues. Reverb is how long a sound stays around in the room after it's been sung, spoken, or played. That's reverb. RT3060 is a measure of that, how long a sound stays. It's a measure of decay. So when you see RT3060, it's 30 seconds, 60 seconds. That's the time domain, and then you can see the decay rate, and fits the definition of how long a sound stays around in the room, right? Okay, so reverberation is a big problem. In small rooms, we have low frequency issues. In larger rooms, we have middle and high frequency reflection issues. Not echo, that's a repeating signal, but reflection issues, pressure reflection, remember? Small rooms, it's pressure. It's reflections too, but it's mainly pressure, modal pressure. In larger rooms, it's reverberation. So every surface, wall, ceiling, each about 17%. I want you to start thinking in macro terms so you can get a handle on this, and then you understand the problem as a whole, then we can bust up parts of it into treatment, surface area coverage, rate and level of absorption, all those subheadings underneath it. But try to get people to understand the big picture first, and then everybody's got an idea about a tactic, but they don't know how it fits into a strategy because they don't know what the strategy is. This understanding will help you with the strategy, okay? So every wall is 17%. Everyone has a different frequency and amplitude. We get constant photos from schools and churches where the same treatment is used all the way around the room. That can't be. That just can't be. The frequency could be the same, but the strength or amplitude is not going to be. So you need a little bit more horsepower on those surface areas. Now you can cheat your way through the process, but you'll end up with a product that's an end result, a sonic signature that won't be acceptable to most members of the congregation and churches and schools and things like that. You have to do your homework. But let's focus on this range. It's funny. Reverberation time, critical ranges are 125 to 500. Look at this graphic. Take a few seconds to study it. Look at the frequency response range. Look at the peak RT3060 time. That 3 second or whatever it is, the high one. Look at that, okay? Look at the range. And that's a typical RT3060 bump. So that's the frequency range you have to focus. So when you start seeing treatment that's 1 inch thick, and you got this is your problem, these don't go together. You can't, it's not going to happen. At 125, you need at least 2 inches. It's better, more like 4, because you want to get a lot of this. At 2 inches, what are you going to get, 30%? 4 inches, you're going to get a little bit more. So you have to calculate. When we specify for churches, large venues, most of our units are 6 to 8 inches deep. And there's a frequency and amplitude reason for that. It's not magic, it's physics. So when you look in a room and you see a reverb time of 4 seconds, you're seeing 3 in that graphic. How about 4 seconds? How about 5 seconds? We shot a church last month, 6 seconds, full range. 6 seconds, big room, of course. But you got to put a lot of sponges in there to soak up all that energy, because each surface area is 17%. You got to get to about a 70% critical mass before you have a real audible impact, before people walk in and go, wow, this is way better. And that's what you want. You want it 100% fixed. You want it 100% right. So your engineers don't have to fight high reverb times trying to mix voice and music for the congregation, for churches and things like that. This is critical. We talked about it, rate and level, proper type. Don't use 2 inches when your start frequency is 125. Our foam is very powerful at 125, but it only gets 30% per square foot. You're dealing with reverb, high pressure issues and high reverb times. You got to get more because the space that you're going to have to treat is going to be limited. You can run the numbers and look at the square footage requirements on each surface area and go, oh, well, there's windows, there's this, there's that. We're not going to be able to get that kind of square footage of coverage. Well, then you're going to have to live with a higher reverb time. And then you have to see, are you going to be able to? Well, if you have to, then you got to lower the amount of energy you put in the room. So the PA's got to be turned down, the band's got to be turned down, everything's got to come down, less energy. Because the room only sees energy, big or small. It's going to react to the energy it sees. So, reverberation, critical mass. I hope this helps. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple of days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.